people like to look at the instant geology, you know, the volcanoes going up and spewing ash.
They're building mountains and eroding them and making deep basins.
This is where all the action happens.
The Earth is a very dynamic structure, constantly undergoing processes of change. Geologists have searched the globe for clues to better understand the processes that directly or indirectly result in some of the most spectacular scenery around the world.
The science as we define it now has really been through a big revolution with the development of the plate tectonic theory that explains to first order how things like earthquakes and volcanoes and mountain building all occur.
Plate tectonics is the theory that Earth's outer layer is made up of plates which have moved throughout Earth's history. Tectonics comes from the Greek word for one who constructs.
The plate tectonics and the movement of the plates on the surface of the Earth is responsible for the now recognizable shapes and that we associate with the continents and with certain areas of the planet. Of course, they weren't always in this configuration. Way back when there was Pangaea, you know, there was sort of one unified landmass.
About 250 million years ago, our Earth had one single giant landmass called Pangaea, meaning all lands. And this supercontinent broke up to create the modern-day continents. This theory, called continental drift, is the forerunner to plate tectonics.
A very astute scientist, a meteorologist by the name of Alfred Wegener, roughly back about 1915 or so, was really the first guy to put it all together. And what he found was a lot of very compelling circumstantial evidence that suggested that the continents had one time been joined and they since had drifted apart, hence the term continental drift. And he found four very compelling lines of evidence. He found that the continents shared common coastlines, so much like a puzzle. You could put these things back together.
And then there were many details of those continents that were known 100 years ago in the early 1900s that supported that idea of the fit of the continents. There were fossils that were found, for instance, in Africa and South America, that were from early reptiles that could not have swum across the Atlantic Ocean. There were old mountain belts that are no longer mountains, have been eroded down, but we see the roots of them in South America. We see the roots of different mountains in North America, and those mountains presumably just go out to sea, but in fact a match for those mountains is found on the other side of the Atlantic.
Along with fossils of plants and animals and the mountain ranges, Wegener found other evidence of similar geological features on separated continents, such as deposits of ice and coal.
The presence of glacial deposits and coal deposits, as they stand now, are very difficult to explain. But if you reassemble the continents into this big landmass that he called Pangaea, all of a sudden these very mysterious glacial deposits make sense.
Despite all the evidence, many scientists during Wegener's time rejected this theory.
Mostly because they could not think of any mechanism whereby the continents could drift away from one another. Nobody could see how they could plow through the ocean basins. And so because nobody could understand how that could happen, they thought he was